All right. So let's look at a couple examples we can compute here. So we'll start with something pretty simple and straightforward, kind of like what we had before. X e to the x dx. All right. So again here, we're going to look at this. This has an algebraic part here and an exponential part here. So when we're choosing our u and our dv, the algebraic part shows up first in our acronym, so we're going to make that x. E to the x is exponential, so it's at the end of the list. Right? So let's say our du is dx here. Our v is e to the x. So this integral is u times v minus the integral of v times du. Okay, so now we just finish this off. X e to the x minus e to the x plus c. All right, pretty neat. Let's look at another example. Kind of similar to this one, but I'm going to change it up just a bit. Let's look at x squared cosine of x. All right. So this function, again, has two parts, an algebraic part and a trigonometric part. So the trigonometric part is second to bottom on the list, so we shouldn't pick that for our for our u, we should pick the x squared part. So u is x squared. Again, that's the first thing on the list. dv is going to be what's left over, cosine of x dx. Okay? So, du is going to be 2x dx. V is going to be sine of x. All right? So, this is going to be u times v minus v du. V du. 2x dx. 2x sine of x dx. Right? So if we look at this part here, x sine x, we actually still can't do that, with any u substitution or any tricks we know. So we actually just have to do another integration by parts. So let's go ahead and let's simplify this a little bit. Or maybe I should, instead of simplify, I should say let's prep this a little bit. All right, so we're looking at this integral right here. U is going to be x, dv is going to be sine of x dx. So then du is dx, and v is minus cosine x. All right, and now we just do this again. So x squared sine of x minus 2. Now keep in mind, we're replacing this integral with integration by parts, so it's negative 2 parentheses the rest of this. So x cosine x, so the u dv minus v du, right? So we get x squared sine of x minus 2 negative x cosine x. Now here I have a minus and a minus, so that makes a plus. And when I integrate cosine, I get sine plus c. And now we can just multiply out that negative 2 if you want. This is fine for an answer, but it'll look a little bit better like this. Right, let's see, minus 2 sine x. And then again, negative 2 times c, we're looking at a constant times an arbitrary constant, so that's still arbitrary. So we'll just leave that as plus c. And there we go. That's all there is to that. Now, I want to do one more example in sort of this little section of examples. But before I do that real quick, this one here, I just want to point out here, You might sometimes have to do 2 integration by parts to solve an integral. You might have to do a u substitution followed by an integration by parts. You might have to do it in the opposite order, integration by parts followed by u substitution. It really depends on sort of what you're working with there. So for a third example here, let's look at e to the x sine x. This integral is going to show off quite an interesting trick with integration by parts. I quite like this one as a concept because we're sort of, well, you'll see. We're going to integrate this, but in some sense we're also not. You'll see what I mean. But also, these types of functions right here, an exponential times a trig function, these are very important for harmonic motion. All right. So if you have a negative exponent on the e here, like instead of x, you had minus x, this would be like harmonic motion with dampening. So it'll oscillate, but the oscillations will get smaller and smaller each time. So if you go on to Math 213, 2 semesters from now, you'll see lots of these functions show up. They're incredibly, incredibly important. But anyway, enough of that little detour. Let's go ahead and do this example. So u is e to the x, dv is sine... Oh, I did this backwards, didn't I? Remember, u should be the first thing in the list. Here we have a trig and an exponential part. So actually, we should pick u to be sine of x, dv should be e to the x dx. Now, as it would turn out, if you started with e to the x for u and sine x for dv, you would actually be fine for this particular integral. But let's keep with our acronym here. Right? So here's our u. du is then cosine of x dx. And v is just e to the x. So this integral turns into u times v minus v du all right. So we're kind of stuck in a similar conundrum to what we started with. We have an e to the x cosine x going on here. This is fine. We'll just try integration by parts again. U is cosine x, dv is e to the x dx. All right, same procedure as last time. So then du is going to be minus sine x dx, and v is going to be e to the x. All right, so let's set this up. We have e to the x sine x minus, let's say u times v, so e to the x cosine x, minus v du, all right, now let's simplify what we got here a little bit. Get rid of all these double and triple negatives. So actually we have a double negative here and then another negative. So this is minus integral e to the x sine x dx. So now we do have a little bit of a conundrum. This is what we started with. So think about it for a second here. What could we actually do? All right, so pause the video if you want. Think about it. See if you can come up with any ideas. All right, so let's talk about what we actually do. Now, in this one here, something very important happens. There's this negative sign right here. Since I have this negative sign right here, I can take this integral and add it to the other side, and the benefit is nothing's going to cancel out. So when I add this piece, maybe let's rewrite the equation real quick, what we have so far. So let's see, e to the x sine x minus e to the x cosine x minus integral e to the x sine x. Maybe it's a little easier to see here, but what we're going to do is take this part and add it to the other side. What that does is gives us 2 integral e to the x sine x dx is e to the x sine x minus e to the x cosine x. Now something you might notice here is now there's not an integral on both sides, so we do need to add back in the plus c. So we're really moving over the integral, but we're leaving a plus c behind. Now, it's a bit weird to think about, I understand, but that's what we want to do. And now to find the actual integral, just divide by 2, right? So we get e to the x sine x dx equals 1/2 e to the x sine x minus e to the x cosine x. And then again, we're just going to leave that plus c on the outside because dividing c by 2 doesn't do anything. And there we go. That's it.